Yo, what is going on, Algebra 1? It's your teacher, Mr. Lopez, coming at you with another lesson, Chapter 11, Section 3 on dividing polynomials. Now, I'm going to go ahead and warn you. You know I'm a straight shooter. You know I'm that kind of teacher that will tell you when lessons are supposed to be easy and when lessons are often misunderstood. And you're probably thinking, well, Mr. Lopez, you say everything is easy. Well, because, it kind of is easy. But this lesson is one of those lessons that students often don't like. We're going to talk about dividing polynomials. And we have one simple, clear objective to divide polynomials. Imagine that. All right. So before we go ahead and jump into the dividing polynomials, I'll give you like my honest opinion is it is not that bad. But it is quite lengthy, and students get kind of lazy and they don't like doing these things. But it's my goal today to show you that this form of division is really not that different than the type of division you learned back in, like, let's say, 4th grade. All right, so if you can do 4th grade math, I think you can get this one. All right, so let's go ahead and do a little bit of a recap of 4th grade math. Sound fun? Let's do it. All right, so I went ahead and wrote a couple of problems for us, and we have a real clear, simple mission to divide. And what we're going to do is we're going to use something called long division in order to divide. Now, this is something you learned probably back in 4th grade. Fun fact, 4th grade is about the age when students really start disliking math, mainly because of long division. Usually cool with addition, subtraction's okay, multiplication's kind of annoying, but you learn the speed drills and you learn your multiplication tables and it's fine. But the long division comes up and they force you to do step-by-step kind of a boring math work to get very little satisfaction out of getting the right answer. So I can understand why long division is not really all that loved, but it's really not that bad. So let's go ahead and do like a real simple reminder of what long division is. Normally, if I was going to try to divide 1052 by 2, I would go ahead and see how many times can 2 go into 1, and you would say 0 times. So 0 times 2 is 0. I would subtract, or I'm going to say I'm going to change the sign of 0 and I get 1. I bring down a 0 and I can do the same thing. I can ask myself the same question. How many times does 2 go into 10? 2 can go into 10 5 times. So 2 times 5 is 10. I change the sign. I get a 0, bring down a 5, ask myself the same question. How many times does 2 go into 5? I would say twice. 2 times 2 is 4. Change the sign, I make that negative. I add them together, I get 1. I bring down a 2, and how many times can 2 go into 12? I would get 6. 2 times 6 is 12, and there's no remainder. So my final answer is 526. All right, that's not that bad, right? It's not that bad. All right, what if we went ahead and looked at example B and did the same exact thing? 2 can go into 1 0 time. You might be thinking, is it necessary to put that 0? No, but it is a placeholder, and that's kind of nice. All right, bring down the 0. 2 can go in and get this, and get a 0, and bring down a 5, and do the same thing, and get 2, and then I would get 4 and get a 1, and then bring down a 3, and then get 13. It can go into it 6 times, and I would have a remainder of 1. What do we do with the remainder? Well, 2 possible answers. All right, 1, you can put a decimal, and then you guys can bring down a 0, and you can, go further and then get a decimal number. Or you can put this as a remainder of 1, right? Or you can write this as a mixed number, and because my 1 is my remainder, all right, I would get this 1 goes up there, and I would get a 2 over here, because this guy would go there, and the divisor is the same thing as the denominator, and I would get 526, let's do this in blue, just to kind of keep this consistent, 526 and 1/2. Interesting. All right, so let's go ahead and review the steps for long division. So the steps for regular long division, I went ahead and typed them out for you guys. Step number 1 is you guys are going to multiply. You're looking at the number on the outside, also called the divisor. You're multiplying it by a number and figuring out, asking the question, how many times can it go in that first number? Or in this case, maybe the first 2 numbers. That does work. All right, then after you multiply, you change the sign. Some people would say you subtract, but I'm going to go ahead and say you change the sign. And then after you change the sign and add, change sign and then add, you go ahead and bring down the next digit. And then you kind of repeat the process until it eventually ends. And if you have a remainder, then you would put the remainder over the divisor and you would have a mixed number. All right, sound familiar? I know, guys, I know. We'll come back to those long division steps. Keep those fresh in your mind. We'll definitely need those soon. We're going to talk about how to divide polynomials, and we're going to start with the easiest way to divide polynomials by dividing by something that's called a monomial. Let's change the color just to make it a little bit brighter. All right, mono means 1, and monomial means 1 term. So we're going to divide 9x cubed minus 6x squared plus 15x, and we're going to divide it by 3x squared. Now this is one of the easiest ways to divide because we're going to divide this just like Shia LaBeouf taught us how to divide using GCF. We're going to consider this kind of be like a GCF, and we're going to divide every term by the same number. We're going to divide by 3x squared, 3x squared, 3x squared. All right, so this one actually isn't that bad. We're going to go ahead and try to divide. 9 divided by 3 can reduce to 3 and 1. So I end up with 3. And x cubed divided by x squared is like subtracting the exponents. So I end up with 1x. Next, I would divide, and negative 6 divided by 3 is negative 2. And x squared divided by x squared is 1. So we just leave that alone. All right. Last, we can go ahead and divide. 3 and 15 is going to be a 5, and x divided by x squared is the same thing as x to the negative second power. But remember, we have a Captain Jack Sparrow hiding right here. We're not supposed to have negative exponents, so the preferred answer is 3x minus 2 plus 5 over x squared. And we kind of want to leave our exponents to be positive, and this is a perfectly fine answer. Notice this is actually left in standard form with the highest degree to the first in the front, with the constant behind it, and the negative exponent in the back. All right, so dividing by a monomial is what we always hope for because it is one of the easier ways to divide. We're just going to divide each individual term by the regular monomial. All right, so not too bad. All right, now comes the fun stuff. Now comes the stuff that I live for. Stuff like dividing by a binomial. Now, this is definitely more complicated than what we just did. Dividing by a binomial, you cannot simply just do 3d squared minus 4d plus 13 and divide each by the outside term d plus 3, d plus 3, d plus 3. This would not work. This actually makes our life way more complicated. So forget I said anything about that. Let's just go ahead and get rid of that right here. Instead, what we're going to use is a process called polynomial long division. That's right. The whole thing I was talking about earlier, guess what? We're going to use it. So let's go ahead and set this up. This is going to be 3d squared minus 4d plus 13. And we're going to go ahead and divide this by our divisor, d plus 3. d plus 3. All right, cool. Now, I went ahead and I copied down the steps from earlier of regular long division. It's my goal to prove that this type of long division is not very different. But there's some key similarities and differences. So here's what I'm going to do. The first step I'm going to do is I'm going to go ahead and circle the lead term. Now, one thing that we should go ahead and point out is that all of our terms have to be in standard form. They have to be in order from highest degree to smallest degree with a constant in the back. So d plus 3 is in standard form. and I have a highest degree of 2, then 1, then none, so we're good to go. Now what I'm going to do is I'm going to go ahead and multiply. I'm going to ask what would I have to multiply d by to get 3d squared? Well, if I multiply d by 3d, and I put 3d up there, 3d times d is the same thing as 3d squared. And because I have a binomial, I have to use my distributive property. So 3d times 3 is going to be 9d. So the second step was to change the sign and then add. So what I'm going to do is I'm going to go ahead and change the sign of both my terms. I'm going to change this to a negative color, or I'm going to change the color to negative, and this is also going to be a negative sign now. And when I add them together, these guys cancel out, and I end up with negative 13d. Fair enough. The next step was to bring down the next digit, and I have plus 13. So I'm going to go ahead and start my whole process over again, just like long division asks us to do. Ooh, this should be white, and then do this, and then, all right, cool. Now, let's go ahead and ask ourselves again, we're going to multiply d times what to get negative 13d? Well, I would multiply by negative 13. So minus 13, and when I multiply negative 13 times d, I get negative 13d. When I multiply negative 13 times 3, I get negative 39. And now I'm back here. I'm going to step 2 again, change the signs, then add or subtract. So if I change the signs, this changes to positive, this changes to positive, and what happens? Well, like magic, these guys cross out, and I'm left with, what was that? 52. Now, there's no other digits to bring down, so whenever we have a remainder, our remainder is going to be positive 52, and put it over our original divisor, d plus 3. I end up with my answer, 3d minus 13 plus 52 over d plus 3. Isn't that fun? The answer is yes. Do you feel like we need more practice? Well, I do. So let's go ahead and look at Got It question number 2, and they're asking us to do some more long division. How do I know it's long division? Because I have a binomial. So this part is going to go inside our box, 2m squared minus m minus 3. This is in standard form, so we're good to go. On the outside, I have m plus 1. All right, so we're going to do the same thing, the same thing. All right, we're going to go ahead and follow our steps. Step 1, we're going to multiply. We're going to ask, what would I have to multiply my lead term to get it to turn into 2m squared? Well, 2m times m is 2m squared. And then because I have a binomial, I have to distribute. So 2m times 1 is 2m. Now I'm going to go ahead and change my sign. My sign will change to negative, and this will change to negative, and I subtract. These guys cancel out, which is what I need to happen. And negative m minus 2m is negative 3m. The next thing I do is I bring down my negative 3, bring down the next digit, and I start my whole process over again. All right, I ask myself, what number would I multiply m by to get negative 3m? It would be negative 3. So negative 3 goes up here. Negative 3 times m is negative 3m. Negative 3 times 1 is going to be negative 3. Now I change my sign, and I add them together, and I end up with 0. So it looks like this answer, it doesn't have a remainder, so my answer is going to be 2m minus 3. All right, so not every answer is going to have a remainder. If I did have a remainder, I would put the remainder over the outside term. But in this case, my answer would be 2m minus 3. How would I check my answer? Well, if I multiply them out, m plus 1 times 2m minus 3, I should get my my original term. All right, let's go ahead and look at example number 3. And example number 3 is very similar. It presents a slightly different problem from what we're used to seeing. They want us to divide q to the 4th plus q squared plus q minus 3 divided by this. Now, this might look very similar to what we just did, but something's off with this one. Something's missing. Something's wrong. And maybe it's because I've been doing this for a lot longer than you have, and I can tell. All right, but before we answer this question, let's go back to our basic examples of long division, just to kind of keep all this stuff in perspective. If I asked you guys to divide 2042 by 2, you would easily be able to do this. Now, my question for you is, do all of these digits matter? You might be thinking, yeah, duh, that's why they're there. All right, what would happen if I erased this 0 from the problem? Is it the same division problem? You're thinking, well, I don't know, where are you going with this? Well, all right, I would say no, it's not the same problem, because that 0 is important. Even though the number 0 doesn't have a value in itself, it is a placeholder, and it represents a very specific spot. If I didn't have the 0, you might think this is 242. And with the 0, it makes it 2042, and that's a different problem altogether. So yes, we needed to have the 0 there. That is a placeholder that has to be there. Now, I was reminding you earlier that we should always have these things in standard form. And while the degrees do go from the biggest to smallest, from 4 to 1 none, there's a missing degree there. And we don't have a q to the 3rd power. We have q to the 4th, then it goes to 2nd, and then we have a 1 there, and then none. But we actually have to have a q to the 3rd power there. So this was missing one of the place values. And now we can go ahead and figure out the rest of our division. Now notice I put a 0 as a coefficient. I can't just put a q to the 3rd power there, because if there was a 1 in front, that's a whole different value. But 0 times q to the 3rd is still 0, so it's like it wasn't there, but it kind of was. Now we can just do regular long division. I'm going to go ahead and start by circling my lead term, and I'm going to go ahead and just follow the steps. What would I multiply q by to get q to the 4th? I would multiply by q cubed. That's fun to say. All right, I distribute, and q to the 3rd power times q is q to the 4th power. Q to the 3rd times -1 is going to be negative q to the 3rd. And notice now my place values are lining up correctly. That's important. We want to make sure that we have that 0 coefficient in there. All right, next step, I change the signs, and then I subtract. So this becomes a negative, and this becomes a positive. And now I can go ahead and add them together. These guys cancel out, and 0 q to the 3rd plus q to the 3rd is q to the 3rd. I bring down the next digit, and that's q to the 2nd power. I got to ask myself again, what would I multiply by? Well, it looks like I would multiply, in order to get q to the 3rd, I would multiply it by 2 more q's. So plus q squared. And when I distribute, I get q to the 3rd minus q squared. Now I can go ahead and change my signs. All right, I change the sign, and I would get, this cancels out, and I would get q squared plus q squared is going to be 2q squared. I bring down the next term, plus q to the 1st power, and I can start my process all over again. All right, let's go ahead and figure out q times 2q would be 2q squared, and 2q times negative 1 will be negative 2q. Then I go ahead and change my sign, and let's see what we have left over. These guys cancel out. Q plus 2q is 3q. Bring down the negative sign and negative 3. And hopefully, well, this will be the last time that we have to do this. What would I multiply q by in order to get 3q? Well, q times 3, so positive 3, will be 3q. And 3 times negative 1 is negative 3. I change my signs and cancel out, and I get a 0 remainder. So it looked like my answer was q cubed plus q squared plus 2q plus 3. And that would be my answer for this problem. Oh, I love this stuff. This is fun. Alright, y'all still there? Y'all ready for the last example in this long lesson? I hope this is making sense because it's very logical step by step, and for the same reasons that you didn't like regular long division, you probably don't like this. But it does make sense. Alright, last question. Alright, we want to go ahead and try to figure out, let's erase this because it's not going to apply to this question. Alright. What is negative 10x minus 1 plus 4x squared divided by negative 3 plus 2x? Okay, so this question is not that different than what we have been doing. I want to ask you, what is wrong with this problem? You're probably, well, the problem is it exists. Okay, let me ask you, is it in the right order? No. Alright, this is not in standard form. If I try to write this in standard form, I would have to rewrite this as 4x squared minus 10x minus 1. Cool with that? Alright, so my highest degree is 2, 1, none. That's cool. All the place values are filled because I have a degree of 2, degree of 1, degree of none. That is fine. Alright. Is this in the right order? You would say no. I would rewrite this as 2x minus 3. Now notice this is negative 3 and this is still negative. We have to keep the sign intact. And this is in standard form from a degree of 1 to none. So we're good. Alright, let's go ahead and circle my lead term. And we're going to ask ourselves 2x times what gives us 4x squared? Well, 2 times 2 is 4. And x times x is x squared. So 2x times 2x is 4x squared. Then 2x times negative 3 is going to be negative 6x. Alright, now I'm going to go ahead and draw my line and change my sign. Okay, that rhymed. Alright, so draw my line and change my sign, and now I can go ahead and add these together. These guys cancel out, and negative 10x plus 6x is negative 4x. And now I'm going to go ahead and bring this dude down to negative 1, and we can start the process over again. So we're going to go ahead and this is going to be a shorter one. We're going to ask ourselves 2x times what gives us negative 4x? Well, if I multiply by, let's say, negative 2, negative 2 times 2x is negative 4x, good. And negative 2 times negative 3 is going to be positive 6. So I'm going to go ahead and put my negative 2 up here. And when I draw my line and I change my signs, it's catchy, isn't it? Change my signs. So now this is going to be a negative sign. Negative 4x plus 4x cancels out. And negative 1 minus 6 is negative 7. There are no other terms that we can bring down. So our remainder is going to go at the top, and our divisor is going to go in the denominator, 2x minus 3. So our answer should be 2x minus 2 minus 7 over 2x minus 3. Well, that does it for this lesson. I'm sure you guys had a lot of fun learning about polynomial long division. You'll have even more fun doing the homework. If you have any questions, just make sure that you come and ask me during my office hours. I will gladly help you with this. I know this is not everybody's favorite thing, but it could be yours. It might not be everybody, but it could be yours. All right, so practice these problems. Good luck. Follow the steps, and I think you can do it. All right, see ya. Bye.